Find all theta such that sine of theta equals negative root 2 over 2. List 8 smallest positive solutions. First, we find the general solution. Solving trigonometric equation, we will need to use the unit circle or the table. It is better to use the unit circle. We see the sine of theta is negative only when theta is in the third quadrant or the fourth quadrant. This means the angle that we find have to be in the third and the fourth quadrants, and there are infinitely many of them. Sine of theta is defined to be the y-coordinate on the unit circle, but only on the unit circle. So we would draw the line y equals negative root 2 over 2. We see that this line, this horizontal line, intersects the circle at two places. One is in the third quadrant, where the x-coordinate is what we don't know, but the y-coordinate has to be negative root 2 over 2. Another one is in the fourth quadrant. The x-coordinate, we don't know, but the y-coordinate has to be negative root 2 over 2. But then, there is only one point in the third quadrant where the y-coordinate is negative root 2 over 2 on the unit circle is when x is negative root 2 over 2. Y is negative root 2 over 2. Similarly, in the fourth quadrant, there is only one point on the unit circle where y is negative root 2 over 2, and that is when x is root 2 over 2. Using symmetry, we see that the angle in the third quadrant where we obtain the terminal points has to be 5 pi over 4, and the angle in the fourth quadrant where we end up with the terminal points has to be 7 pi over 4. Both 5 pi over 4 and 7 pi over 4 are in the interval 0 to 2 pi, the initial revolution or the initial rotation. We see that if we were to obtain all solutions, then we simply take the initial or the principal solution and add 2 pi to it, or subtract 2 pi to it, and we can just simply add 2 pi as many times as we want to obtain infinitely many solutions. We can do the same thing with the second principal solution. So the general solutions are theta equals 5 pi over 4 plus 2k pi. Each 2 pi is one rotation. We keep adding 1 2 pi, 2 2 pi, 3 2 pi, and so on. K is an integer. We can also subtract 1 2 pi, subtract 2 2 pi, subtract 3 2 pi. In this case, k is an integer where k can be 0, plus or minus 1, plus or minus 2. When k is 0, we end up with 5 pi over 4, which is the initial or the principal solution. The other solutions are theta equals 7 pi over 4 plus 2k pi. And again, this k can be positive or negative. If we want to have 8 smallest positive solutions, then we simply add 2 pi each time. Theta equals, the first positive solution is 5 pi over 4 and 7 pi over 4. These two solutions are in the initial rotation or period when k equals 0. Next, we set k equals positive 1. When k is positive 1, we have 5 pi over 4 plus 2 pi, which is 5 pi over 4 plus 8 pi over 4. So this is 13 pi over 4. We simply add 2 pi, which is 8 pi over 4 each time. The next solution is 21 pi over 4. The next solution is 29 pi over 4. So we end up with 4 positive solutions, starting with the initial solution, 5 pi over 4. We can do the same thing with 7 pi over 4 by adding 2 pi, which is 8 pi over 4 each time when k equals 1, k equals 2, and so on. 7 pi over 4 plus 2 pi is 15 pi over 4. 15 pi over 4 plus another 2 pi, which is 23 pi over 4. Add another 2 pi, which is 8 pi over 4. We obtain 31 pi over 4. We now have 4 smallest positive solutions that satisfy this equation, and we also have the general solutions as well. If we want to list the solution in ascending order, increasing order, we would need to list them as 5 pi over 4, 7 pi over 4, 13 pi over 4, 15 pi over 4, 21 pi over 4, 23 pi over 4, 29 pi over 4, and 31 pi over 4.